Welcome. Obvious, my name is Deko Mohammed. Today we want to focus about the structure and bonding. Remember, the last time we talked about the chemical families. So today we want to talk about the structure and bonding. I still remind you, please subscribe, like and share for more free videos. Welcome. So, under the structure and bonding, we are going to see the types of bond and the type of structure they form. Types of bond and the type of structure they form, and also the characteristics, because we have several characteristics that different bonds have. So let's first talk about the types of bond. We may have ionic bond, we have the covalent bond, we have the coordinate bond, we have the metallic bond, and etc. These are the main bonds that we want to talk about. So I want to begin with the ionic bond. Let me start with the ionic bond. So under ionic bond, what you have to know that ionic bond is a bond. This is a bond that exists between. This is a bond that exists between metal and non-metal. It's a bond that exists between metal and non-metals, which involve transfer of valence electron. So the first thing under ionic bond is that it exists between a metal and non-metal. For ionic bond to exist, there must be a metal and non-metal, and there must be transfer of electron, the valence electron, the outermost energy level, that is the valence electron. So that transfer of the valence electron will form the ionic bond. So we may have example of metals like sodium, potassium, and then non-metals like chlorine. So you may find when sodium reacts with chlorine, we may have sodium chloride. Now sodium chloride is a compound consists of sodium and chlorine, which is a metal and non-metal. So we can draw sodium chloride here. Let's take sodium chloride. Remember that sodium atom, the electronic arrangement of sodium atom is 2 to 8 to 1. While the electronic arrangement of chlorine is 2 to 8 to 7. Now, when you're going to draw the ionic bond for this sodium chloride, this outermost valence electron, sodium will transfer this one valence electron to chlorine, such that now chlorine will have 2, 8, 8. There is transfer of valence electron. So you are going to draw sodium with 2, 8 and chlorine with 2, 8, 8. Now let's draw sodium first. Sodium for 2, 8. So here we'll have 2 electrons. Here we have the 8. Now you can see this is sodium. Remember now, this is sodium. Here on top of here we indicate positive. 1 electron, 1 valence electron. Now this is 2 to 8. This is sodium. Now chlorine will gain that 1 electron and it will have 2, 8, 8. Remember, when drawing the bond, we use the dots and the crosses. Now, if we use here the cross, here we are going to use the dot. Chlorine we are going to use the dot. But the valence electron being transferred, you must indicate it with a different. But if it was dot, you retrace by the X or the cross. Now let's have the chlorine 288. Can have here 1. Can have here. Sorry, if I use here dots, if I use here crosses, let me use the dots. 1. I'm going to have 2, 2, 2, 2. Then lastly we have another one. This will have 2, 2, 2. Now the one being transferred, you show it with a different, like the use is X. Now this is chlorine. This is chlorine. Negative, which will have 2, 8, 8. This is chlorine. Chlorine. Now, sodium chloride. Sodium lose one electron to chlorine, such that now chlorine will attain stability by 288. Therefore, ionic bond is a type of bond that exists between a metal and non-metals, which involve transfer of electrons, transfer of valence electrons. Now that is one of compound of the ionic bond. We may have another one. Let's draw another one. The last one, another compound. We may have calcium chloride. Like calcium chloride, it means if I were to write the calcium chloride, the formula for calcium chloride, it will be CaCl2. Since calcium, the valence of calcium is 2, chlorine is 1. So if they exchange, chlorine will end up with 2. Now this means, remember that calcium atom, the electronic arrangement of calcium atom is 2 to 8, 2 to 8 to 8 to 2. This is the electronic arrangement of calcium, 20, total 20. And the electronic arrangement of chlorine is 2 to 8 to 7. Such that now, this valence electron will be transferred to 2 chlorines. Such that one chlorine will gain 1, will have 2, 8, 8. Another one will gain 1, will also have 2, 8, 8. Now, these two valence electron of calcium will lose to 2 chlorine. Now, if you are to draw, you draw calcium for 288 and chlorine for 288. Let's draw it. Let's draw. Now, let's have the calcium. Let me use the dots for calcium. See here, 1, 1. I have another. There I draw the next one. 2, 2, 2, 2. Then the last one. You'll have 2, 2, 2, 2. Now this is calcium. Remember, now it is 2 positive because it is going to lose 2 electrons. It's going to lose 2 electrons. This is calcium 288. Calcium ion. This is calcium ion with a positive sign of 2 positive, 288. Now we are going to draw the chlorine. Remember, there are 2 chlorines. Now we can show in 2 ways. You can draw 2 chlorines, one here, one here. Then you draw the bracket on top of it. But you can also draw 1, then you write here 2 to show that there are 2 chlorines. Now let me draw 1, then I bracket with 2. So let me draw the chlorine here. I have the first electron, the first 2. Then the next will have 8. Next will have 8. Then the last one will also have 8. 8. But remember, the electron which were gained, you have to show it by difference. So we draw like that, which is 288. Now here it's negative. So we'll have to draw here 2. It means 2 chlorines are gaining electrons, 2 chlorines. So we have 288. That's how we draw calcium chloride. Now, ionic bond is a type of bond that exists between a metal and non-metals, which involves transfer of valence electron, which we have seen. So in case you have been asked, but remember in the periodic table, you may not find sodium. You may be given the symbols. You may have X or Y. So if you are told X, you use X. You don't use here sodium. You just use that X because the actual symbol because the symbols are not the actual symbol of the elements. Now, after knowing how to draw the ionic bond, you have to know the characteristic of ionic bond. The characteristics. We may have the characteristics of ionic bond. Now, under the characteristics, when we talk about, let's say, characteristics. Before characteristics, remember that this bond, they form the giant ionic structure. The structure for this bond is giant ionic structure. Now let me talk about the characteristics. We can say they dissolve in water. Because the main reason why ionic bond dissolves in water, because it consists of different polar charges, positive and negative, which attracts them together. That's why they dissolve in water. That is one characteristic of ionic bond. They dissolve in water. Another characteristic of ionic bond is that they have high melting. They have high melting and boiling point. The main reason why ionic bond have a high melting and boiling point is because they have strong ionic bond, which is very hard to break it. That's why now they have high melting point and boiling point, because ionic bond is strong. It's a strong bond. Then lastly we say ionic bond, they conduct electricity. They conduct electricity in molten state or the aqueous. Molten state or aqueous, but not in solid state. Since in solid state, since the solution, since in solid state it is fixed, it's not mobile. Solid state is not mobile. Thus fixed. It means the main reason why ionic bond conduct electricity in molten state is because in aqueous state they are mobile, but in solid state they are not mobile, they are fixed. That is the last characteristic of ionic bond. Now we have seen how to draw the ionic bond and the characteristics. Now that's all about the ionic bond. Want to go to the next bond. So we are done with the covalent bond. We are done with the ionic bond. Now want to go to the covalent bond. Covalent bond. You can say the covalent. Under covalent bond. Now we say this is a bond. This is a bond that exists between nonmetals, which involve sharing of electrons, donated by both atoms. Now covalent bond, it exists between the nonmetals, pure nonmetals. There is no metal here. Nonmetals, and involve sharing of electrons. There is no transfer of electron here. They share electrons, which are donated by both the atoms. Let's take example of chlorine molecule. If you look at chlorine molecule, we have chlorine molecule like this. If I were to draw the chlorine molecule, under the covalent bond, we can use the outermost electrons, unlike the ionic bond, which we are drawing all the structure. But under covalent, we just use the outermost electron. Like if you look at chlorine is 2, 8, 7. We are only going to use 7, the outermost electrons. Now let's have, it means 2 chlorines are bonding, chlorine to chlorine. Let's see. we have this chlorine like this. Then we have another chlorine like that. Now 7. It means let's have the first 6 chlorine here. 1, 2, 3, 4, 5, 6, 7. Then this will bring 1, 2, 3, 4, 5, 6, 7. Now you can say here is chlorine. This is chlorine. Now it means they share electrons. They share electrons. They share electron. This chlorine donates this one electron, and this chlorine donates one electron. So we have chlorine to chlorine. That's how we draw the covalent bond. And remember, covalent bond, they don't conduct electricity, but they have high melting and boiling point. And covalent bond, their structure is called giant atomic structure. Giant atomic structure. All covalent bond, they don't conduct electricity except graphite. Graphite, because graphite, remember, we only use the 3 valence electron. So in graphite, there is 1 electron which remains delocalized. That's why graphite conducts electricity. But diamond, we use all the 4. All the 4 carbon atoms are used for bonding. So there is no delocalized electron in carbon. That's why carbon does not conduct electricity, but graphite conducts. Graphite is the only forms covalent bond that conduct electricity because of the 1 delocalized electron. But majority of covalent bond, they don't conduct electricity. I hope it's well understood. That's all about the covalent bond. We may also have the metallic bond. So before metallic bond, we may have the coordinate bond. Coordinate bond is also called the dative bond. This is a special type of covalent bond, but it means dative bond is a bond which involves between nonmetals and the sharing of electron, but the electron which are shared is only denoted by 1 atom. That's the difference. In covalent bond, both the atom they donate. If it is chlorine, they donate. But in dative bond, only 1 atom donates. Example, we may have the carbon 2 oxide or the ammonia. Example of dative bond, we may have the copper 2 oxide or the ammonia. And normally it's being indicated by an arrow. The dative bond is a special type of covalent bond. If you are to draw the carbon 2 oxide or the ammonium ion, you are going to see that only 1 atom will donate the electron. That's why we'll have dative bond. It's a special type of covalent bond because it exists between nonmetals. If you look at carbon 2, carbon and oxygen, both of them they are nonmetals. But this one, only 1 atom donates the electron. That's all about the dative bond. If I go to the metallic bond is a bond that exists between metals. They only exist between metals. Under the characteristic of metallic bond is that metallic bond conduct electricity in both solid and molten, because metals are good conductor of electricity. All the metals, they have delocalized electron. So you can see. So as we said, the metallic bond, it exists between the metals. What you have to know that this metallic bond, they have high melting point and boiling point, because metallic bond is a strong bond and it's not easy to break. That's why it has high melting and boiling point. Another one is a good conductor of electricity. Because all the metals, they have delocalized electron. If you look at sodium 281, these are delocalized electron, valence electron. If you look at potassium 2881, if you look at calcium 282, if you look at aluminium 283. But if you are to compare, if someone asks you, compare the electrical conductivity of sodium, if I were to compare sodium and aluminium, the conductor of electricity, I will say aluminium is good than sodium, because Aluminum has 3 delocalized electrons, unlike sodium, which has only 1 delocalized electron. But generally, metals they conduct electricity because of the delocalized electron. That's all about I can say about the metallic bond. Finally, but before that, we see the metallic bond they form giant metallic structure. Metallic bond they form the giant metallic structure. If I talk about the simple molecular structure, like sulfur compound exists between a simple molecular structure, and this simple molecular structure compounds they have low melting and boiling point. They don't conduct electricity. All those characteristics are under simple molecular structure. I hope we have tackled a brief analysis of the bond. But next time we are going to see several questions that will combine all the 3 topics: the structure of an atom, the chemical families, and also the structure of bonding. Because when a question in periodic table is stated in an exam, it covers all the 3 topics: the structure of an atom, the chemical families, and the structure and bonding. In that, now we have done those topics. Next time we are going to see several questions under periodic table. We are going to discuss them and see how we can apply them. So up to now, it's bye from me. I hope you enjoy the class. May God bless you. Thank you.